And this is, if you've been doing Zoom calls or webinars in the last 2 months yourself, you realize the first 10 minutes of anything is getting the telecommunications to work correctly. I also don't know if I'm speaking loud enough because I don't have my microphone on, so I'm using the built-in microphone. So if I'm coming across too quietly, you'll need to tell me and I'll try to speak up loudly. I'd plug in the microphone if I could find it, but I don't know where it is in the house. And very good. Okay, so everyone's entered. So Anna, will you turn on your microphone and let me know if you can hear me? Okay, well then we'll move on down the line. Manesh, can you hear me? Mr. Kumar?
Yes, I can hear you, sir.
Excellent. Very good. Let's see. Next one is Chabol Superada. Can you hear me?
Yes, I can hear you.
Excellent. TJ Brock.
Yeah, I can hear you.
Anna Chavez. Ian Hamlet.
Yep.
Awesome. John Lopez.
Yes, I can hear you.
Terrific. Let's see. So the only one who I didn't get audio back from was Anna. So Anna, if you have a chat, send a chat message just to be sure that you can hear me. I mean, I obviously want to hear you too, but it's more important that you hear me. So let me bring the, let's see, hopefully I don't crash the connection. Oh, that was good. And let's see, chat, see more. And we'll get started real quickly here. There should be a question mark at the end of that chat. Okay, so I'm, as Anna waits to get back to us, I'm recording these calls, so if you miss them, they'll be recorded and I'll turn them in MP4 files and put them to my YouTube account. I'll provide a link for that. But that takes several hours to do, so just be aware of that. So it should be ready every evening. One of the first things we'll have to do on the call is, for the future ones, because this one I remember to turn the recorder on, is you'll have to remind me, are you recording? Because I tend to space cadet that, and you can't do anything afterwards. I'm also going to push the picture of my self over to the left of the screen in an attempt to, when I share the screen, I want to have as much of the screen possible. So I want to welcome everybody, and this is a relatively new teaching modality for me. First, the online part, and second, trying to condense a graduate course realistically into a little less than 5 weeks. So we will make the best of it as we can, and as questions come up, we will cope with them. So I've technically taken roll. Now there's another member of the course who is going to be having to do it by recording only. So I'm going to have to go painfully slow on a few of these upfront lessons so that they have a fighting chance to be able to figure out all the technology. I have a little script here, that's what I'm checking. Okay, so talk about the modality. Okay, so the modality, that's a fancy education word for using the internet to do what we used to do face-to-face. And I'm ingesting, oh, that's right, I'm not sharing my screen yet. So one of the nice benefits of the calls as we move on in the class, you can take turns sharing your computer screen. So as questions come up on any of the activities that require that, if there's problems, we can certainly do screen sharing and attempt to address the problems. So I'm now going to share my screen, and hopefully I picked the right one. All right, so with any luck, my I'm going to have a hard time not there we go. I'm going to have a hard time not using profanity when I try to move stuff around. Why does it do that? I want you to stay right there. Refuse to, so it's going to go to the right side. Okay, fine. So I'm going to appear on the right side. I was trying to set up for the left, but fine. Yeah, we'll minimize that. So you should be seeing my screen, and what you should see is a web browser. And if that's not what you see, you need to chime in now and stop me. So the course is going to be delivered through this website. This is actually just a portal to some other resources. So the URL to get to what you should be seeing on the screen right now is www.rtfmps.com. That's all you need to type into a browser, and it should come up like this. This additional extension that'll appear there automatically. And so this is a website that's hosted on a commercial server. The hosting company is called justhost.com. It's physically sitting on a server rack on an abandoned oil platform in the North Sea in international waters. So I'm pretty sure I'm sharing this with the Russian Federation and some other nefarious users. But the advantage of it being international waters is that there's a little bit more freedom than you would have on an onshore server. I don't need that freedom, but it was a good price, and I've used them for 10 years, and they're a good company. This stuff has like almost 100% uptime. So it's unlikely that the server is going to fail. Not impossible, but unlikely. So this is the main page. And to go to our class, if you take the teaching icon, the teaching navigation tab, there's one here at the top, there's one at the bottom. If you're doing it on a small frame device, something like that, there's these three lines here, and that has the navigation tab. So you choose teaching. Let me get rid of that. I'm going to go back to a big screen device. And there's two links here, the Moodle site and the content repository. I'll go to the content repository first, although my intent is that's not the main way to get to the course material. So the material for this course gets stored in this location. So it's kind of an older style web server. Has a description of the course, prerequisites, software. That's all incorrect, but those two are correct. The software is not right. The syllabus, which many of you have seen already. So on the syllabus, this is pretty much what the course is. The only thing I want to bring your attention to, the reading references past the 4th of June. So the 5th of June onward, anything without these asterisks is not correct yet. I haven't cross-referenced them, and I'll be working on that over the next few days, and I'll get this updated. Other than this column changing, this is the planned layout for the class. And I have a horizontal line here on this schedule to indicate the different weeks in the class. So this is today, the 2nd of June, and we should be ending the 3rd of July. And let's see, as for grade, it says there's examinations and exercises, and we'll discuss those shortly. Those aren't anything to be scared of. In fact, in this context, these are actually pretty preferable to the face-to-face way of doing it. The individual lessons are shown on this page here, and these are called accordion buttons, and so you would click on an accordion button to take a link to a lesson. Today is lesson 1, the introduction. A typical lesson layout will have a description. This one's empty right now, and then a set of lesson materials. And for the ones I have pre-recorded information, there should be a link to a YouTube video. So I'm going to take this link. I'm not going to play a YouTube video for you over a phone call. That's kind of stupid. I'll play a few seconds of it. And so this is a YouTube site, and the pre-recorded videos are attainable that way.
Surface water hydro.
There's also any presentation materials will be in the presentation file directory. So there's either the PowerPoint. This has an example and a lesson. In some cases, there'll be PDF files. The PDF files tend to be quite a bit bigger, but if you don't have PowerPoint, that's the only way you can look at the content. And if there's any data files, they'll be in this data file section. In this particular example, for lesson 1, there's no data files. There's not even a data file directory, so you'll get the 404 message. And if there's spreadsheets or R scripts, they'll be located in the XLS RSource files. So that's the repository, although that's not the intended way to get to it. All the readings are here. These are not indexed, so you might have a challenge going directly through the reading list to find a particular reading, but they're supposed to be cross-referenced for each lesson. So let me go look at one that I'm pretty sure I have that done already. So here will be what a typical reading cross-reference will look like. And then these are links to the particular content. Exercises are served through the Moodle site, which I haven't discussed yet, but copies of them are located here. So for example, don't let these 18 ones terrify you. I only intend to have 10 this summer session, so I'm working on combining some and throwing some out. So when we get ready to go to the learning management system, it looks like this. And actually, let me go in through the front door instead of the side garage door. And so if we're here and you're at this page, the way to get to the learning management system site is to click on RTFMPS Moodle site. And this class is Surface Water Hydrology. If you want to do guest access, you can go in as Gomer Pyle, USMC. But all of you have an account here on this Moodle site. I tested them last night. I logged in as each of you, and it worked. And you should have received an email from me with the login credentials. So I'm going to log in as James Bond. I think that's the way I set up his name. If I have trouble, I'll switch to administrator, but I want to try to log in as if I were a student. I hope that's the password. Oh, we lucked out. Okay, so here is the class layout, and I'm simply scrolling through to make you nauseous. Whenever you're logged in here, if you want to get to the course content source, you take this page. It's right here at the top of your course layout. There's one called Announcements. In my life of using Moodle, I almost never use announcements. I could probably take that out, but it'll break something, so I'll just leave it there. Links to the course content sources, and it'll take you to that portal that we were just at, and then it'll take you to another portal when we get to Share Hydro. I'll discuss that a little bit later in today's call. And then the individual lessons are grouped pretty much by week. So this week is fundamentals. Next week will be processes. The week after that, we'll talk about surface runoff in some detail. After that, routing in some detail. Then probability modeling in some detail. Historically, probability modeling usually comes early in a class, but I've decided to move it to later date so that some software that I want you all to explore and employ is actually working right. And then we'll round out the session with a little bit on stormwater quality. I've never used HMS as a quality model, so I'll be learning new stuff then too. I've used SWIM and just picked a couple of topics in stormwater quality to round out the lesson. And this may look an awful lot like an undergraduate hydrology class, and in a way they are, except that we're going to go into more detail on how you would analyze particular situations. And some expectation that you would write your own scripts is necessary rather than just rely upon something like HMS and other software. And those are important, so we'll put some effort in that too. And then I'm also adding some additional material on using the stormwater management model. It's often ignored as a hydrology model, but it actually has some pretty meaningful hydrology capabilities, and it has the added bonus feature that the hydraulics is correct. So it has correct hydraulics, and they tacked on hydrology models to enhance its utility in practical applications. Okay, so that's the layout of the Moodle site. Some important things. Each of these lessons, this is how I'm ultimately going to take attendance. So if you miss it and you watch the video, we'll run through lesson 1 really quickly here in the Moodle site. So when I click on lesson 1, it's going to present a set of pages that you work through the pages. There are some questions as it moves along, and you need to complete the lesson. It doesn't count for much of your course grade, but it's the only way I can track from the standpoint of assigning a grade as far as the university is concerned, that you worked through the lesson. I think it's probably to your advantage to, for each lesson, look at the course content version of the lesson first, because you're not on a timer at that point, and then possibly watch the video, then work through the lesson in the Moodle site. Looks like James Bond has already completed lesson 1, so it may not let me take it again. So you would click on it. Oh, good, it is going to let me take it. And what it does is it presents either graphics or narrative. And then you, when you're done with a particular page, you click on the next page. And it keeps track of your completion status. And what you want to do is complete every lesson, no matter how dull and boring it is. So Mr. Bond will click next page, because the first page just shows some surfer, and it has an introduction to the course. It tells what the purpose of the course is, to examine rainfall and evaporation, soil infiltration property, runoff and snowmelt processes, hydrologic modeling as it applies to surface water hydrology, and then we're going to look at a couple of model applications, HMS and SWIM. And if you're satisfied with that page, you'll choose next page. And classic definition of hydrology: the study of the occurrence, circulation, storage, and distribution of surface and groundwater on the earth. And engineering hydrology is kind of the same thing, but we're interested in quantifying amounts of water in space and in time. Goes on to the next page. So an important warning: when I was I programmed this particular lesson almost 2 months ago. And at the time, I didn't know that I wasn't paying attention to where these buttons were going, and so they flip around on you. What you don't want to do is accidentally hit beginning, unless you really want to go to the beginning, because that kind of negates, in our case, 14% of completion. So I've gotten better in the later versions. Kind of have previous to the left, next page is immediately to the right, and I don't have this third one in. I figured out how to disable that. So it had a definition of a watershed. We'll see that again actually in the lesson on watersheds. And then I discussed what a hydrologic system is. Where you see this, oh, it doesn't have editing. Where you see CMM, that means Chow Maidment Maze, which is one of our reading options. And so if we want to see a reading option, this is where some trickery comes in. We can go to the reading list. Chow Maidment Maze is right there. It's a pretty big file, so it will generally take it a while to load into your browser. And this is where I should break out as Tom Petty and the Heartbreakers, singing The Waiting is the hardest part. But that may not be appreciated as fun. And ta-da, it's here. And so when it has a particular, I don't think those page links don't work, don't even use it. This I think I got from a Taiwanese website. Because at the time, they haven't signed an international convention on copyright. And if we go back to the lesson, it says, look at page 5. And so whatever that thing, we're talking about the systems concept right here. And so when you see CMM page 5, that's what that means. If you see WB, that's a different book. That's the Kindle book that's in the it's referenced in the syllabus. And then the mandatory hydrologic cycle. So the references here. So you have the clouds come on shore, they precipitate. In this case is rainfall. A fraction of it infiltrates. The other fraction becomes runoff, makes its way back to the ocean. Part of the infiltration gets into the groundwater system, makes its way to the ocean, it evaporates and goes back and cycles away. And then the next page has the surface water portion identified. I'm going through this quickly because there's a pre-recording where I spend some more detail. Groundwater component, and then a system diagram where it's trying to conceptualize that picture, which itself is a conceptualization, into a block with flux terms. So here's the entire system, ignoring the atmosphere. You have rainfall in, evapotranspiration out, any surface water inflow in, surface water outflow out, groundwater inflow coming in, groundwater out. And you notice that those are the only flux arrows. And those are used in something called a water budget, which actually is a fairly important expression of the behavior of hydrologic systems throughout the semester. It's hidden away in many instances, but it's the tool by which most of the process models are explained. And the hydrologic equation in words is something like the rate of inflow minus the rate of outflow, and this is for a system boundary, is equal to the rate of change of storage of the quantity of interest within that system. And plus, to be consistent with our chemical engineering way of viewing the world, plus the rate of internal mass generation or destruction. That last term is usually set to 0 and we ignore it. We could express it using our calculus approaches. So where I is inflow volume, the time rate of change of that becomes a inflow rate, outflow rate, storage rate, and then generation rate. And if you look at equation 224 in Chow Maidment Maze, it's pretty much the identical equation. They use different notation, different letters of the alphabet, and the internal generation term is not even listed in their representation, but it's the same equation. Then we can break this system into two parts, surface part, and once we make that cut, we now have to accommodate discharge and recharge from the groundwater system. And so in that surface water diagram, appropriate budget would be things like inflows are rainfall, surface water from outside the boundary, recharge from the groundwater. Outflows, evapotranspiration, surface water leaving the boundary, that's our runoff term, infiltration to groundwater, and then storage is whatever doesn't get out of the boundary. Water levels in lakes, rivers, ponds, water stored on leaves and other surfaces. Groundwater system, we've made that cut, and so what left of surface water becomes groundwater recharge. What leaves the groundwater system becomes surface water recharge. And then looking, this should say groundwater. Appropriate budget. So inflows to the groundwater system are flow from outside the boundary, recharge from the surface. Outflows, groundwater flow out of the boundary, discharge to the surface. And storage would be water levels in the aquifer. So those are the analogous terms for surface and groundwater. Then we want to recombine the system. So mostly what I'm trying to indicate with this drawing is that when we tear the system apart, we have to generate these connections. When we put it back together, they collapse and become part of the whole. And then, so this will be typical of these lesson layouts. This is why you probably want to look at it ahead of time on the content server before you actually attempt the lesson. I have it programmed that to get out of the lesson, we ultimately have to get the correct answers, or at least what I have declared correct answers. So, the figure below is to the right in this case, is a schematic of the occurrence, circulation, groundwater on the earth. Now it has the word runoff, so that's not groundwater. A collection of connected components that form the hydrologic cycle, maybe. Schematic of lumped and distributed modeling, I haven't even talked about those. Conceptual model of the surface water, conceptual model of groundwater. I think the best answer for this is conceptual model of the surface water system. So if we get correct, it's going to tell us what our answer is, and it's going to have some feedback. But if it's correct, we can move on. So if we had chosen the wrong answer, it would have recycled us back to the question. So pretty much by trial and error, you should be able to get the right answer for anything. So this picture is, this picture is a watershed. So let's find out. The closest thing to a watershed is a topographic area that collects and discharges surface stream flow through one outlet or mouth. Actually, let's do a wrong answer. We'll do a geologic formation. So if we do the wrong answer, we get nope. You want to try again. And then we can move on through the lesson. And then the definition of hydrology, take that from the first slide. And then this is an example that requires a calculator. We have precipitation coming in, infiltration, runoff, and evapotranspiration. We're told the area is 65 square kilometers. We want to calculate the value of R, and we would apply that hydrologic balance equation. Now I have some prior knowledge that the correct answer is going to be 9.8 million cubic meters, I think. Yay! Continue. And then conceptual model for developed environment. The key for development is this urban area. And we have completed the lesson. And once we completed the lesson, then we can return to the class, and it marks the completion. More importantly, it keeps track of our scores, so we can see, and that's how these lessons are intended to be produced. Now, this first week, there's also this quiz. You should do the quiz after the exercise because unfortunately, at the time I was programming it, I have some duplicate material, so it's going to seem somewhat repetitive. That's not my intent. That was just learning to program the device. So that's the introduction to that. And then the exercises, let me click on that. The exercises are shown here. You can look at it, and it will take an eternity to download. And so they should come across as PDF files. So here's an exercise set. Spinning beach ball means crashing is imminent. So this one just has some internet research, a simple problem in chow mein bit maze. This one right here is very similar to the question in the lesson. This one actually gets repeated in quiz 1, so you want to do it here, and then quiz 1 will be easy. And then there's a later lesson on watershed delineation. I'm going to do one by hand, just so you know to never ever do that again. And that's exercise set 1. So let's suppose we've completed that. What we want to do is you would click on submission, and it will accept a program to take a tape archive, a zip, PDF, or text file. My preference is that you upload them as PDFs. So I'm going to go ahead and hopefully I have a PDF on my desktop to simulate this. There's one. Okay, so it's obviously not the correct answer. So when you've created your exercise report, go ahead and upload it. And it's set to accept a 10 megabyte file, which should be big enough if you take some care in compressing the file before you attempt to upload it. If you were to upload a Word document, those things are huge for some reason. Okay, so now it claims it's there. Then you would go to Save Changes, and you have the ability to make edits, which means you can delete the file and put a new one up. So what I suggest is, as you're doing your exercises, especially if you get the easy part, if you're a person that does the easy stuff first, which I think is usually the most productive, go ahead and generate the PDF document, throw it up onto the server, because pretty much what that does is it holds a place on the server. If for whatever reason you never get completed, or you forget, or something goes wrong, at least that first file gets stored as a draft automatically. So when the due date times out, if you can't get it done by the due date, you'll get pretty substantial partial credit because something's there. If it comes up empty, you're doomed. So we'll save the changes. I think I have this program. So it's submitted, it's not yet graded, and on Monday the 8th, which is when it's due, 12 in the morning, I've got to reprogram that. Then after that time passes, you can't upload anymore, but in the intermediate time, you can keep changing it as you need. And the important thing is, it's going into a repository that's unique to you. So only you and myself can see it. So you don't need a long, drawn-out file name. I don't need your R number ever for this programming environment. Okay, let's go ahead. I think I got all the important stuff. I believe you can see other people in the class. Well, that was kind of bad of me to do that. So at least a few of you have verified that it is indeed that you can log on. That's awesome, actually. That is really awesome. I'm glad you all did that. Okay, I think that's all I need to do here for right now. So let me go ahead and log out. And the trick is getting back to the, there we go. Okay, so there's a, let me make my checklist. We have done a tour of www.rtfm. We did a tour of Moodle. Let me explain the Share Hydro. Okay, so this is an experiment. I hope this goes well. There's an environment called Share Hydro where I have pre-made a set of desktops as a service that run EPA Swim, Heck HMS, Peak FQ. It actually has R Studio running on it. And only in this video, I'll use Share Hydro 1 as an example. So each of these is going to request just a password. And these are shared spaces. So for this experiment, this semester, I don't care which of these you use. Just remember which one you use so you can go find your files if you have to. I should have stayed logged in the Moodle. We'll deal with that in a second. Let's go to Share Hydro 1. So the reason there's 5 is this doesn't work good if 2 people are logged into the same one at the same time. As far as I know, it'll work, but it doesn't work well, and you may end up breaking things. That's okay if you break it. I'm not encouraging you to break it, but anything gets broken is pretty fixable. So you should get this screen here. It says no VNC, and that's a open source project that I use to provide a portal to a computer through a web browser. So you notice we're doing everything in a web browser. You shouldn't need any special software. Hit connect, and let's see, this is, the password's going to be VNC, all lowercase, VNC, the #, which on my computer is shift 3. Well, I guess that's the hashtag sign. I don't know what it is. Hashtag. And this one is 001. So you now know the password protocol for the other 4. Hit send password and you get that. Because I entered the wrong password. VNC, hashtag, the word ONE. Yay. And so this is what you should see. Get that out of the way. Get that out of the way. So this is the desktop, and something you might want to do on your own machinery when you're using this. If you go over here to this area right here on the left, and I'm spending some time there right now because I'm only doing the recording at 5 frames a second, so I want your eye to be able to catch that. There's this little tab sheet. If you click on the gear, that's a settings tab, and I have it on my computer set to remote resizing. What it's going to default to for you is none. So you may find it useful to go to remote resizing. And what that does, you are the remote. Your browser is the remote. It'll attempt to resize it to fit your browser window. And that seems to work the best. And then when you're done, you can close this tab. We're going to be here again a little bit later on. And then, so here's this desktop. So this happens to be running on a Linux server somewhere. You'll notice it has a very strange URL. That's intentional because there's a lot of traffic to send the image both directions. It has to get compressed and fired down a pipe. In this case, it's pipe 6082, but at the server, there is no 6082. There's some shenanigans that go on there that assign it to a local host pipe. Anyway, that's kind of geeky. Basically, it works. So we have a bunch of these files that say launch Peak FQ, launch RStudio, launch Swim, launch Engage, launch Heck HMS, and those are the ways to start the programs. Because if you were to look at what the reason the launcher script is there is that in the absence of the script, you would have to type that command into a command window. I haven't even shown you how to do that. But if you just double click on the script, it was good. I hope it didn't take that. That was not the one I wanted to demonstrate with. That's the most unreliable of all these software. Okay, I think we got lucky. and it launches a script. I'm going to exit that because that's for later in the semester. So let's look at RStudio, for instance. I put my mouse on it, I've right-clicked, and I press execute, and it takes a few seconds for the software to load, and you have a functioning version of RStudio. And the thing in RStudio, I'm just trying to remind you to do, is you want to go to a directory that makes sense for your computer. And the way I have these set up is in desktop, RScripts, so now it's pointing to the correct place. The reason that's important, if someone's running the Hydro 2, a Hydro 3, a Hydro 4, there's nothing to stop it from pointing to the wrong directory. You don't have to worry about hurting anything because it won't allow you to write to the wrong directory, but it can read from the wrong directory. And we'll go ahead and source what's there. Okay, it claims it can't do that, which makes sense to me because I think that's lesson 12. But so you have a fully functioning program there, and you can do stuff like create an RScript file. So I'm going to take the value of, call it object X, and I'm going to concatenate. I'll do 4 things like that. Okay, that's not very exciting. And I'm going to make y equal to x squared. There's plenty of resources on the internet for how to write scripts in R. Interesting. Guess I gotta save it. There, so it correctly concatenated it, and then if I want to, I'm taking a shortcut here, and we've just plotted it. So now you have functioning RStudio. You don't have to install it yourself. If you want to install these on your own computer, that's fine, and that may be advantageous to you. But I provided this computational environment so that you don't have to. More importantly, it will help us later on when we have to diagnose problems with each other's programs. We just all go onto this environment together and can make changes. And so when we're done, quit R, quit it again, and I don't think I'm going to save any of that. There's also swim, and it takes a little while to load, but it's a fully functioning swim environment, and by design, the path to where I want you to store files would be home Hydro 1 desktop, or home Hydro 2 if you're in Hydro 2, or Hydro 3, or Hydro 4, or Hydro 5, EPA swim projects, Hydro 1 projects. And I have an example here called Lazy Brook, which we'll go ahead and open. And it is the same as this location. So you can't double click on these and have anything happen. It just look at you like you're, it's like, what do you want me to do, human? So here's a swim model, run it. And at this point, you don't have to know much about swim at all. So we just ran it. Choose the okie dokie. Let me go ahead and turn off the backdrop. And I will go ahead and plot the flow, and that's what it's supposed to look like. So that is there, no downloading required. And as far as I know, this will work on a netbook. So if you have just a Google netbook, a little $100 netbook, you'll be able to use all this stuff. Save changes, no I don't. And then the last one that's important for today is, if I launch it, I always forget if I've launched it or not. HMS takes a while to launch, and I may have actually started 2 instances. Okay, no, good. Well, I did start 2 instances. I'll delete that one. And HMS, same thing. I think there's one there called My Live Model. And go ahead and select a simulation run, hit the flaming drop. And the reason I'm doing this is when you log in, you want to maybe go through the set of unit tests yourself. Be sure that the stuff runs without, you don't necessarily have to know how it's working, you just got to be sure it does work. Okay, so we're done with the run. Let's go look at the output. And okay, so I'm zooming out using the scroll wheel on the mouse, and that took me a while to remember how to do that. So I've used HMS a lot in my career, but I never use it a lot for more than a few weeks at a time, so I forget how to do stuff pretty quickly. And there's nothing wrong with that. Hopefully I picked the correct thing. Let's look at the output. And so we just did a simulation of producing hydrographs. So that should give everybody in the class the necessary computational resource for the computational hydrology part of the class. We looked at peak FQ, which is late in the semester, and there's one other one here called Engage, which will be useful for watershed measurements. And so this is just a digitizer. And let's see if we can trying to pull up a recent run. So this one is also a very clunky install. Do import samples. And here you want to change the view to the original image. And so here's an image, and you can then use the digitizer to digitize a watershed boundary. So I've done something wrong, but you get the point, and you can look at should be able to look at the digitizing window. When we get to this in a class meeting or two, I'll go ahead and do that example again correctly. I forgot 2 steps. I had to introduce a scale. I thought it would actually do an area for us right off the bat. So that's a useful tool that in the past has been really hard to get running on computers. Some people can download it and get it to work. Some can't get it to work. Here it's kind of working, and you'll find it useful at least for one exercise this semester and possibly later on in your professional work. So all the tools I'm providing they're free. And they are not superior to things like a GIS that's integrated with HMS. These are for when you don't have that. The advantage of that is that you actually have to understand more of the hydrology that's being analyzed with the tool. All right, and so that completes the Share Hydro introduction. I've technically gone through the lesson. So when you're done with Share Hydro, I want you to remember to disconnect. So you go to the tab here. This bottom icon is the disconnect icon. So you need to remember to disconnect before you leave the server. Otherwise, it'll be left hanging and it'll require a reboot. And I won't know that, and it's not going to send me a message. I'll know it when I start getting 7 emails on the thing's not working right. And that's going to be my usual solution, will be to reboot it. But if you remember to disconnect, it doesn't seem to happen. And then you can leave the Share Hydro environment. Okay, so now I'm going to shut up and ask if you have any questions.
Sir, what was the username or password to share Hydro to log in?
Let me go ahead and type it on the screen so y'all can see it. That's the easiest way. I'm going to go ahead and keep forgetting how to make the, trying to make the font big. That'll work. So there's one called, there's 5 of them. There's Hydro 1, Hydro 2, and 3, 4, and 5. So Hydro 1, its password is VNC and you can pick up the pattern from that. 3 is THRE, 4 is FOUR, 5 is FIVE. And they're all, as of right now, they're all pretty much the same. I mean, there's no files laying around in them. So I only have 5 environments created, and there's 7 people, and they're intended to be shared. So I'm okay if you share, because I figure the probability of 7 people using 5 at once is low. But if you leave files there, oh, that reminds me of something. I have to show you how to move files back and forth. If you leave files there, you probably want to make a subdirectory within within whatever storage directory, and just put your name in it so that another user doesn't accidentally destroy your stuff, or you don't forget it. But the preferred way of moving files is I'm going to demonstrate that right now. Does that obviously that answers your question? You got that? Okay, cool. So here's the preferred way. Here's the preferred way to move files. Let me log back in. Okay, so James Bond is logged in, and we'll go to Share Hydro 5. This way I'll test to be sure it's working. VNC pound FIVE. And if you get this on the initial screen, that's okay. Just go ahead and ignore it. That's the desktop manager isn't quite configured right. But every time I try to configure it right, it breaks something, so I'm leaving it be. Okay, so here we are at Share Hydro, and we have our Moodle site, and we have my Moodle site. Let's suppose I want to move a file to Share Hydro. So each of you has a private file section in your Moodle site. So James Bond has something called flow duration. Well, we use lazybook.txt because it's a pretty small file. Okay, so Moodle's log into your regular thing, and we go to Share Hydro, and if we go down to this picture of web browser, we want to choose Firefox. And it takes a little while to load. It takes a long while to load. There we go. So here's the trick. We're going to go ahead and log into our Moodle site from here. And we will now have a way to connect to it. So I'm logging in, same user. So if I want to bring a file to my Share Hydro site, select a file, download it. I'm going to go ahead and I'll just save it. And it should download to home downloads. And there it is. And what's in it's irrelevant. So that's how to move a file from your Moodle site to Share Hydro. You can go the other direction. Well, there's not much to put in the other direction. Let's see. We can save changes. Go ahead and attempt to upload a file. Create folder, download, add. There we go. To upload a file, you choose the uploader. You browse. Let's just take one of the launcher files. They're text files. Choose open. Hit upload. Save changes. Now we're back at our direct connection. Files there. We can download it and so on. So that's how to move files, is to take advantage of the Moodle application to do that. It's a bit of a hassle, but we're doing everything through the web browser. That's kind of like huge. And I think that's all I need to do there. When you're done with the browser, you just close it. So the only thing on the Share Hydro you've got to remember is to be patient. A lot of the apparent slowness is not at the server end, because I pay pretty good money for it to be fast, but it's at the receiving end. In case of what I'm demonstrating, I'm doing this on my home network, which is pretty terrible in terms of connection speed. And remember, when we leave, disconnect, and we're done. Okay, so any other questions? You probably need to go experiment with this later today when you have a chance, and tomorrow, or if you have questions by email, we can use that route too. So what I would prefer you to do before tomorrow is verify you can log into Moodle, and it looks like most of you have already done that. Go to one of the Share Hydro portals, doesn't matter which one. Verify you can navigate around in that. Maybe move a file there and back, and that should set us up for tomorrow. Tomorrow's topic is supposed to be the Share Hydro demonstration. We'll spend a little more time than I just did today, so that we're all on the same resources for computational hydrology. And if there's no further questions, I'm done. So I'll wait a couple seconds for questions. And if none, have a great afternoon. Well, I have a question before we disconnect. Was I talking loud enough?
I could hear you just fine.
Okay. Well, I will be rendering the recording, and when I make the everyday recordings, I'll put a link into the course repository webpage, and I'll probably just send an email. So the other thing I'm going to do is, I only scheduled this one meeting the first time, but you'll be receiving an email for scheduled meeting for the rest of this week, next week, following week. So five sets of scheduled meetings with the Zoom stuff. I think you can set Zoom up to meet for an entire week. I took some training recently, and that's what they did. So I got to read how to do that. Worst case, I have to send out 27 Zoom meeting announcements. But I'll try to get the rest of this week out to you so you have the URL and the password. And if for whatever reason you can't join the meeting, or if you have to leave, that's fine, because as long as y'all remind me to record it, you'll at least be able to get the recorded meeting. And I hope this works out for all of us. I don't know about you, this is new for me, trying to do the whole thing on the internet. But I'm okay with it. I think we can make this happen. So have a good afternoon, everybody. I'm in
Sir, one last question.
Yeah.
So we start at 10 a.m. today, but on the syllabus it says we start at 9 a.m.
Oh, crap.
I was wondering what the times are for this class.
I'm going to have to go look up what the scheduled time is, because I will stick with the scheduled time that's in the Texas Tech thing. I don't know why
John,
I was
you're
thinking.
gonna
I think
make
it is. I think you're right. I think
hour
it's scheduled 9:30 to 11, isn't it? Or 9:30 to 9:30 to 11. Is that correct? Well, I'll go look it up. That's easy enough. I don't think I can do that fast. I will check with the university calendar, and the invites will be at the correct times. So I apologize for today. So it may be 9:30 to 11, or 9 to 10:30. I think it's probably 9 to 10:30. So look forward to that. And I apologize that I got the timing wrong today. Any other questions? Thank you for bringing that up, by the way. Check.
Dr. Cleveland,
Yes.
where will the recordings be held?
What do you mean?
Like, where will the recordings be found?
I will send you a link to YouTube.
Okay, thank you.
Anything else? Good. So I mean, I'm doing everything with recordings are all going to be at YouTube. I keep backups, and all the content's delivered through this Atomic Kitty. I would have used Blackboard, but when I logged in yesterday, they hadn't set up a Blackboard repository for this class for me. And trying to do it the day before class is a nightmare, so I'm just going to go with this. This has been, I've used this before, but never entirely a web-based class. This is a reliable server, so you're not going to have the server fail badly ever. The Share Hydro, that's an experiment. That may fail miserably at some point, and we'll adapt. Okay, well then I will get all this out to you for tomorrow. If there's nothing else, have a great afternoon, everybody.
You do, Dr. Lever.
Remember how to disconnect with it. Stop that, and